Okay, so in this lecture, I'm going to review quickly the Coulomb's law and the electric field, and we will review that by solving two exercises on these two concepts. Okay, let's start with one exercise. In this exercise, actually, we will also use the concept of Newton's second law. So a sphere, a small sphere of mass m equals 7.5 grams. So this is 7.5 times 10 power minus 3, because we divide by 1,000 to make it kilogram. Okay. And the charge Q1, 32 nanocoulomb. So this small sphere has mass 7.5 grams and has a charge Q1 32 nanocoulomb. So this is 32 times 10 power minus 9 coulomb. Is attached to the end of a string and hangs vertically. A second charge of equal mass and charge Q2 equal minus 58 nanocoulomb, so this is now the second charge, is located below the first charge, a distance d 2 centimeters. So they are separated by 2 centimeters, which is 0.02 meter. Draw the free body diagram on charge Q1. Okay, so we want to draw free body diagram on charge Q1. Now, what are the forces acting on Q1? So let's start. We put a sphere, remember? Okay. What are the charges acting on Q1? First and always, there is the weight. So there is weight. Okay. Then what else? There is a string. So there is tension. Okay. So there is no surface. So there is no normal. There is no surface. So there is no friction. But there is a second charge. What does it do on the first charge? It either attracts it or repels it. And in this case, it attracts it or repels it. It attracts it because they are opposite charges. So there is an additional charge, F. Okay, it's an attraction one. So let's give them names. So this is tension. This is W. And this is F21, because it is the force charge Q is doing on charge 1. This tension, weight, and force. This is the free body diagram. Before I continue, I choose x-axis or y-axis, and here everything is on one direction. So I will call it x-axis, and I'm free to choose it upward or downward. So let's take it upward, because it's not moving. Okay, if it's moving, then I have to choose it along the line of motion, but it's not moving, so it's still along the line of motion, but it can be either pulsed up or down. Okay, now using Newton's second law, find the tension in the string. Okay, so here I will have to use Newton's second law, and we need to use to get the tension. So here I will use summation of Fx equal to MA, or summation of Fy equal to 0. Okay. If I use summation of Fy, I will not go anywhere because I don't have anything on the y-axis, which is here. It will be perpendicular to the x-axis. Everything is on the x-axis. So I will use summation of Fx is equal to MA, but they are not moving. The charge is not moving. Everything is standing still. So this is 0. Okay. So now I have Tx plus Wx plus F21x is equal to 0. Tx is all of T. Wx is minus W. F21x is minus F21. This is equal to 0. Tension minus mg minus. What is the magnitude of this force F? It is K, absolute value of Q1 times absolute value of Q2 divided by the distance between them square, okay, or r squared. Here they are calling it d, so we have to call it d. So this is equal to 0. So I have tension minus, let's plug in numbers, 7.5 e to the minus 3 times 10, which is the gravity, minus k, 9 e to the 9 times Q1 is 32 e to the minus 9 times absolute value for the second charge, which is 58 e to the minus 9, okay, divided by the distance between them. So this is 0.02 square. This is equal to 0. Okay, I will get tension minus 7.5 e minus 3 times 10 is 0.075. Okay, minus 9 times 10 power 9 to Q1 this gives me 0.04176. This is equal to 0, and I get the tension to be 0.12 meters. Okay. Okay. Last part, it says if t prime is equal to 0.18, find d prime. Okay, so I will be doing exactly the same thing. I will say summation of fx is equal to 0. That is t prime x plus wx plus f21x is equal to 0. The only difference that now I have t prime. So this is t prime minus w minus f21 x minus f21. This is equal to 0. So now t prime is 0.18 minus 0.075 minus f21. Now this is 9 e to the 9 times 32 e to the minus 9 times 58 e to the minus 9 divided by the distance. So now our unknown is the distance. This is equal to 0. Okay, and if we solve this, we will get 0.18 minus 0.075. So this is 0.105 minus 1.6704 e to the minus 5 divided by distance squared is equal to 0, or 0.105 is equal to 1.6704 e to the minus 5 divided by d squared. And if you just do the math, you will get 0.105 d squared equal 1.6704, or d squared equal 1.6704 divided by 0.105 implies d prime. This is d prime, okay? So I will get d prime square equal 1.59 e to the minus 4 implies d prime is equal to square root or radical 1.59 e to the minus 4, which will give me 0.0126 meter, which is 1.26 centimeters almost. Notice here that the distance is now less than 2 centimeter, and this is why T prime is higher than T, because the distance between the two charges is closer, so the force would be higher. Okay, the tension force is related to this force. So if this force is higher, then this tension is higher. Let's do another exercise. Okay, a small sphere of charge Q equals 68 microcoulomb. So this is 68 e to the minus 6 coulomb. Okay, this is microcoulomb. And mass 5.8 grams. So this is 5.8 e to the minus 3. Is attached to a light string and placed in a uniform electric field, E, that makes an angle 37 degrees with the horizontal. So this is the electric field on a charge Q. The opposite end of the string is attached to a wall and the sphere is in static equilibrium. So it's in equilibrium, which means acceleration is equal to 0 when the string is horizontal. Draw a free body diagram of the sphere. So again, we bring our sphere. What are the forces acting on it? There is tension. There is tension in the string. There is weight always, okay? And because there is an electric field, implies there is a force F. How is the direction of F? Here I have to pay attention. This is positive, implies F and E are same direction. Okay, so this is F. This is tension. This is weight. Okay, so this is the free body diagram. Then I draw my x-axis and y-axis. So the object, if it will move like this. So this is the x-axis and this is the y-axis. Okay. Using Newton's second law, determine the magnitude of the electric force F on the sphere. Okay, so what is the Newton's second law here? Which one we will apply? If I use the summation of fx, so it's either summation of fx is equal to 0 or summation, in this case it's 0 because acceleration is 0, or summation of fy is equal to 0. Let's start with summation of fx. So on the x-axis I have the tension, but do I have the magnitude of the tension? No, it's actually asked in part 3, they're asking me to get the tension. So I cannot use summation of fx equal to 0. I have to use summation of fy equal to 0, which means fy plus, there is no normal here, plus wy plus tension y is equal to 0. Fy, let's do it here. So I have this angle over here. I have this angle. So this is fx and this is fy. Just like to do it properly. So this is fx and this is fy. Okay, so fx is adjacent to angle theta. So fx is f cosine theta and fy is opposite, so it is f sine theta. Okay, and they're all both positive, so I don't have to worry about this. How much is theta? It is 37 degrees. So we will get back. So I come here, fy is f sine theta plus wy, it is minus w, plus t, yt is along the x-axis, so there is nothing. So now f is my unknown times sine theta, it is sine 37, sine 37 times 0.601 or 0. Okay, minus w is m times g, m is 5.8 e to the minus 3 times 10. This is equal to 0, and I will get f is equal 5.8 e to the minus, or this would be 0.058 divided by 0.6, and this will give me 0.096 Newton. Okay. Now, part C, deduce the magnitude of the electric field. So here you have to deduce it from the chart, from part B. I have to remember that the electric field and F are related by F equal QE. F equal absolute value of the Q times E implies E is equal F, which is 0.096 divided by the charge Q, which is 68 microcoulomb. And I get the answer 1411.7 Newton per kilo. Part D, find the tension in the string. So here the tension is along the x-axis, so I have to use summation of fx is equal to 0. I will be left with minus t plus fx is equal to 0. So tension is nothing but fx, which is f cosine theta. So tension will be f 0.096 times cosine 37, and I get tension is 0.077 Newton. Okay, so in this exercise, we worked on the electric field and we merged it with summation with the laws of Newton's. Okay, so that's it for this lecture. Tomorrow we will have more.